There are insects which see in the ultraviolet. Many flowering sensory abilities. There are insects which see in the ultraviolet. Many flowering plants have the flower pattern in the ultraviolet to attract the insects. All sorts of garish signs, arrows pointing to the pollen, and signs in bee language saying, "Free eats, come this way," which we can't see because we only see visible light. But the insects that know about ultraviolet light see those signs fine and pollinate the plants. Bees that recognize the polarization of sunlight. Pigeons that can detect magnetic fields of 10 to the minus fifth Gauss, 100,000th of a Gauss. Such a tiny magnetic field that scientific instruments to measure such fields in space have only been developed in the last decade. There are pit vipers that can observe the world in the infrared and strike the prey when it's dark. There is a French grasshopper which has on its back a kind of thing that looks like a radio antenna. It sends audio messages to female French grasshoppers, which they enjoy receiving. There is an African fish called Gymnarchus niloticus, which sets up an electric field in the water around it and discerns predators and prey by sensing a change in the electric field which it has set up. A sense completely different from any that we have, us humans. Now, that's just a slight hint of the variety, remarkable abilities of organisms on the Earth. Where did they come from? How long have they been around? Now, if I could find some fossils, I would be extremely happy. Thank you, Bill, because the fossils give us some reminder that there has been life around for a while. This is a single vertebra from the fossil of a single vertebra from the spinal column of an enormous ugly dinosaur called Iguanodon, which trudged around maybe even the British Isles a few 100 million years ago. And if we had one in this room, he would just fit. Iguanodons and other dinosaurs do not exist anymore. All sorts of kinds of life have disappeared. Many more varieties of life have become extinct than exist today on the Earth. Here is a fossil of a crinoid, which lived in the ancient ocean bottoms and waved around there. There are no crinoids on the Earth today. And here is a lovely, beautiful jewel of an organism called a trilobite. Trilobites lived as long ago as the Cambrian period, about 500 to 600 million years ago. They, some people think, hunted in herds on the ocean bottoms, had beautiful compound eyes, some of them much larger than this, and there are no more trilobites on the Earth today either. Now, 600 million years is not very much in the lifetime of the Earth, which is almost 4.5 thousand million years old. I hope you will forgive me if I use American billions henceforth. An American billion is 1,000 million. Let us look at fossils that are microscopic. If you take a rock and slice it thin, and are lucky, you might find something like this sphere with inclusions in it. There is a detailed interior architecture which perhaps you can make out. This is what you find from a rock 45 million years old. Here, a rock 900 million years old. Here, one 1,100 million years old. Here, 1,800 or 1.8 billion years old. And here, 3.1 billion years old. And in fact, things like this have now been found in rocks about 3.5 billion years old. These are bacteria and blue-green algae. They are the simplest organisms on the Earth, but they are not all that simple. They have a remarkable interior architecture They are very clever at turning one chemical into another chemical, at making exact copies of themselves. Therefore, these bacteria and algae could not be the earliest organisms. They needed a long period of time before then for them to evolve. The Earth is only about 4.5 billion years old, and in its earliest history was probably unsuited for life. For example, we believe the surface was molten, and that makes it uncomfortable for living organisms if the rocks are melted all over the planet. So life could not have come into being as early as 4.5 billion, and could not have come into being as late as 3.5 billion. There seems to be only a small period of time in which the origin of life happened, at most a few 100 million years. 6 days was once a popular hypothesis. It is not excluded by this evidence, but it could not have taken longer than a few 100 million years. Now, if there's a process which happens in a period of time short compared to the time available, we are tempted to say it is a likely process. The origin of life happened on a time scale much shorter than the age of the Earth. And that at least suggests that the origin of life is in some sense easy. It's not hard. It happened fast. Something must encourage it, must make it easy. And we have to now ask, what is that something? How does life come into being? Now, if we could understand the origin of life, the origin of a system able to make identical copies of itself, and if there are changes in its hereditary instructions, those changes also are accurately repeated, then we can understand, at least in principle, the entire future history of life. Because we understand from the epochal work of Charles Darwin and Alfred Russel Wallace in the United Kingdom, except it wasn't called the United Kingdom then, I don't believe, how evolution comes about. Mr. Darwin's portrait is sitting here. I don't know if that's exactly a scowl, but I like to think of him as delighted at having come upon such a splendid idea, but he doesn't look extremely happy in this particular picture. Perhaps it was indigestion after breakfast. But the basic idea of evolution is that there are occasional changes, variants, different kinds of organisms which spontaneously arise. Most of those make the organism less suited to the environment, more poorly adapted, and that organism loses out in competition with other organisms. But occasionally, by accident, an organism comes into being which is better able to deal with the environment it's in, that particular millennium, or era, or epoch, and it does better, leaves more offspring, and that variety tends to predominate. There is nothing in this process which is, so far as we know, preordained. It is a process which is extremely wasteful because many natural experiments happen which result in organisms which are less suited to the environment. Only a tiny fraction are better suited and are the aperture, the road to the future. The secret of evolution is an enormous period of time and the deaths of many maladapted, poorly adapted organisms. Now, to understand the entire magnificent panorama of life, the remarkable history over the last few billions of years, we must understand what life is, and in particular, how the first system capable of making copies of itself could come into being. To do that, we have to understand how life today does it. Now, we've just been looking at an astonishing diversity of life. But that diversity is, in a way, misleading. You, for example, look different from an oak